Welcome back. Let's jump right in today.
Sounds good.
If you're anything like me, you probably noticed how, every single app, service, and piece of software you use has suddenly sprouted some kind of AI feature.
Yeah, it's literally everywhere now.
It is. And if you're a naturally curious learner, you've likely had that moment where you stop and just think about the mechanics behind it all. Like, how do we actually know if these AI systems are safe?
Right.
Are they fair? Are they acting responsibly? Or is there just some rogue algorithm doing whatever it wants behind the scenes while we all just, blindly trust it?
It's arguably the defining question of our time when it comes to technology.
Yeah.
We are handing over a massive amount of decision-making power to these systems. From filtering our emails to approving our mortgages.
Oh, absolutely.
And the anxiety around that black box phenomenon where data goes in, an answer comes out, and nobody really knows what happened in the middle, that anxiety is very real.
Which makes today's deep dive particularly relevant for you. We are looking at a highly official, thoroughly detailed document today. It's called the AI Verify Testing Framework.
Yes.
And our mission for this deep dive is to really unpack this. It's basically the ultimate checklist that companies are actually using to prove with hard evidence that their AI isn't just some reckless, unpredictable black box.
Yeah, and to give you some context on exactly what this document is, this framework is specifically designed for a few key players. We're talking about AI, system owners, internal compliance teams.
Internal auditors.
Exactly, external auditors too. It's built to help these companies assess their AI systems against 11 internationally recognized AI governance principles.
11 is a lot.
It is. But what makes this document carry so much weight is its alignment with major international governance frameworks.
Right.
It's totally consistent with guidelines from ASEAN, the European Union, the OECD, and the US. It is very much a global standard approach to accountability.
And like you said, 11 principles covers a massive amount of ground. We're talking about safety, security, fairness, accountability, robustness, all the heavy hitters.
The big ones, yeah.
But, we want to respect your time today, so we are going to zoom in and dissect 3 core principles that are detailed really heavily in our source material. Those are transparency, explainability, and reproducibility.
And honestly, those 3 are essentially the foundation of public trust in artificial intelligence. If a company can't achieve those 3, enforcing any of the rest of the principles becomes, well, incredibly difficult.
Okay, let's unpack this. I want to start with that first principle, transparency.
Sure.
Now, when I hear the word transparency in a corporate setting, my mind immediately goes to some dense, unreadable privacy policy buried at the very bottom of a website.
The one nobody actually reads.
Exactly.
Yeah.
But this framework seems to demand a lot more than just a wall of legal text.
It does. Transparency in the context of this framework is about providing active visibility into the intended use and the impact of the AI system. It's about preventing the exact problems that are caused by opaqueness. The framework specifically states that integrating transparency into the entire AI lifecycle helps ameliorate the problems caused by that black box effect.
It's proactive.
Very. It's not just covering legal bases. It's ensuring the people actually affected by these systems truly understand what's happening.
And the way they enforce this is quite interesting. The framework requires companies to design an in-house policy specifically on communication to consumers.
Yes.
And they can't just throw technical jargon at the wall. The document explicitly says they have to use visualizations or other methods to ease non-technical stakeholders' understanding of how the AI functions.
Which is huge.
It's a fascinating thought, right?
Yeah.
A team of back-end engineers having to sit down and translate a highly complex neural network into a flowchart or like a simple graphic so the rest of us can grasp what it's actually doing.
It forces a necessary translation from machine logic to human comprehension. And this becomes incredibly urgent when we look at the specific rules for generative AI within this framework.
Oh yeah, the rules around generative AI labels really stood out to me.
Right, because the framework states that for generative AI, companies must implement mechanisms like labeling, disclaimers, or watermarks.
So we know what we're looking at.
Exactly. The goal is to enable users to know exactly when they are interacting with an AI system and to understand the lineage of the content. But the phrasing they use is what's really striking here.
Yeah.
Users need to be informed that the output might not be error-free, and most importantly, that, quote, there is no human behind the content with whom they might form a relationship.
That specific line, no human behind the content with whom they might form a relationship, it's a really stark way to phrase it in a dry corporate compliance document.
It really is.
It sounds almost like a warning from a sci-fi novel, but it highlights the real psychological impact these tools can have on us.
It does. And if we connect this to the bigger picture, it reflects a deep understanding of human vulnerability. We are totally hardwired to anthropomorphize things that talk to us.
Oh, for sure, we give our cars names.
Right. We say please and thank you to smart speakers.
I do that all the time.
See? This framework forces companies to proactively break that illusion before it causes emotional or societal harm.
And it goes beyond just chatbots, too. There's a highly relatable example in the text regarding automated decisions. Whenever an AI materially influences a decision, users must be told the factors leading to that decision.
The why.
Right. The example they give is, you're being shown this product because you bought this item. We see that all the time in e-commerce algorithms.
Yeah, Amazon, Netflix.
But this framework makes it a formal requirement across the board.
Furthermore, companies must explicitly communicate to those impacted by the system that the decision was either partially or completely made by an automated system.
You have a fundamental right to know if a machine made the call.
Exactly.
Now, here is where I think this framework actually grows teeth. A company can't just promise that they're being transparent. They have to bring the receipts.
What's fascinating here is the evidence requirement. Every single process in this checklist requires documentary evidence.
They can't just say, trust us.
Nope. To prove they are properly disclosing AI-generated content and ensuring users understand it's not human, they have to provide evidence from things like mental model elicitation interviews.
Okay, mental model elicitation interviews. That sounds incredibly clinical. What does that actually look like in practice?
Imagine setting up a user testing environment. A company brings in a test subject and asks them to interact with a new customer service chatbot.
Okay.
A mental model elicitation interview involves stopping the user during or after the interaction and asking them to describe, in their own words, how they think the system works.
Oh, I see.
They are probing the user's mental model of the tool. The developers are listening to see if the user says something like, well, the agent on the other end is typing really fast.
Oh, wow. Which would immediately reveal that the transparency labels failed.
Exactly, because the user still thinks it's a human.
That makes a lot of sense. They're looking for the gap between what the tool actually is and what the user's brain assumes it is.
Precisely.
The framework also mentions using observational studies where interactions are recorded and coded for behaviors that reveal misunderstandings. They are literally observing users to see if the AI is accidentally tricking them.
And that testing isn't just something you do at the finish line either. The framework explicitly states that companies are expected to consult end users at the earliest stages of AI system development.
So they are gathering this feedback before the product is even fully built.
Yes.
Rather than just, slapping a warning label on it right before it ships out the door.
It's designed to prevent that classic tech industry move fast and break things mentality from causing harm before anyone has a chance to weigh in.
Right.
They have to communicate how the technology is used and how it will be deployed early on in the life cycle.
And when the system does finally go public, the company has to publish what the framework calls model cards or system cards. When I was reading through this part, I kept thinking of them as nutritional labels for AI.
That's a perfect analogy. Just like a nutritional label tells you the calories, the macros, and the ingredients.
Right.
A model card publicly details the mechanics and the health of the AI system. The framework requires these cards to outline the intended use cases, the known limitations, the accuracy, the confidence scores, and the results of red teaming.
And red teaming, just for you listening, is the process where a group of independent experts actively tries to break the system or make it generate harmful outputs to find its vulnerabilities.
Yes, playing the bad guy.
Exactly. So sharing the results of those stress tests publicly is a massive step toward real accountability.
The system card also has to detail the origin and history of the training data. And from a technical standpoint, it even has to explain the architecture.
Like how it's built.
Right. For instance, it has to document how predictive models or foundation models might be combined with rule-based systems.
Let's actually pause there for a second and translate some of that for anyone who might not live and breathe computer science. When the framework talks about combining a foundation model with a rule-based system, what exactly are they asking the company to disclose?
Good question. A foundation model is like the massive generalized AI engines we see today. Systems trained on vast amounts of data that can write text, write code, or answer general questions.
The creative ones.
Exactly. They are incredibly powerful, but sometimes unpredictable. A rule-based system, on the other hand, is old-school traditional programming. It operates on strict if-then logic. If the user says X, do Y.
So the framework wants to know how much of the system is the wild creative AI and how much is just traditional guardrails.
Exactly that. A company might use a foundation model to draft an email response, but use a rule-based system to scan that response and block it if it contains a swear word.
Okay, that makes sense.
The model card forces the company to publicly document how those entirely different pieces of software interact with each other. It is total visibility into the architecture.
And that visibility also extends to data privacy, too. The framework requires companies to publish clear privacy policies detailing how personal data is used.
Yes.
But they go much deeper than just a standard legal text. They require disclosures of third-party engagement, definitions of data ownership and portability, and depictions of the data flow to identify any potential leakages.
They basically have to draw a map of where your data is traveling.
A literal map.
Yeah, and this aligns heavily with existing data protection laws. In Singapore, for example, the document references alignment with the Personal Data Protection Commission's advisory guidelines, the PDPA.
Right.
Outside of Singapore, it mandates alignment with whatever applicable local data protection regulations exist. The AI transparency has to dovetail perfectly with existing privacy laws.
So transparency clearly isn't just the company broadcasting information down to the user. It has to go the other way, too.
It's a two-way street.
Exactly. The framework mandates that there must be processes in place for communicating incidents to users when things go wrong, and crucially, providing a means for end users to report adverse impacts back to the organization.
This really touches on the internal safety culture within these tech companies. The framework explicitly demands that these reporting processes include protection for whistleblowers.
That's a big deal.
It is. If an internal engineer or an external auditor sees an AI system acting dangerously or producing biased outcomes, they need a safe channel to report that without any fear of retaliation.
Okay, so we have a solid grasp on transparency. The company is telling us what the AI is doing, what data it uses. They're testing it on users and bringing the receipts.
Right.
But that brings us to the next core principle in the source material, which is explainability. And I have to ask, what is the actual difference here? Aren't transparency and explainability just two words for the exact same thing?
It's a very common point of confusion. Explainability is actually a specific component of transparency. While transparency is about the broad visibility of the system's existence, the privacy policies, the user testing, the data flow.
The big picture stuff.
Right. Explainability focuses specifically on understanding the internal drivers of the AI model. It's about looking at a single specific decision the AI made and being able to explain the mechanics of why it made that exact choice.
So transparency is reading the menu at a restaurant and knowing where the ingredients were sourced. But explainability is going back into the kitchen and watching the chef cook the meal to understand exactly why it tastes the way it does.
That's a great analogy. The framework defines explainability as ensuring AI-driven decisions can be explained and understood by those directly using the system to enable or carry out a decision.
The framework also makes a really important point about context, right? It says the degree of explainability needed changes based on a few factors, especially the severity of the consequences if the AI makes an error affecting a human being.
It's a highly pragmatic approach. If an AI is sorting your spam folder and makes a mistake, the severity is incredibly low.
You just miss an email.
Exactly.
Yeah.
You don't need a multi-page mathematical breakdown explaining why it flagged a promotional email. But if the AI is a medical diagnostic tool analyzing an MRI, or a system deciding whether to approve a mortgage—
Life-altering stuff.
Exactly. The consequences of an erroneous output are severe. In those cases, the demand for rigorous explainability is paramount.
So how do they actually achieve that on a technical level? The framework mentions running technical tools to determine what they call feature contributions.
Yes.
So they are mathematically analyzing which specific pieces of data push the AI to its conclusion. But we all know that some of these advanced deep learning neural networks are literal black boxes.
They are.
They were so complex with billions of connections that even the developers who built them can't fully trace the exact path of a single decision. So what happens then?
The framework acknowledges that state-of-the-art models might be inherently unexplainable in the traditional sense. If an organization chooses a less explainable modeling approach, they're required to document three things: the rationale, the risk assessments, and the trade-offs of using that AI model.
So they have to formally justify using the black box.
Yes.
They have to write down, we chose this highly unexplainable model because it is 20% more accurate at detecting fraud, and here is our assessment of the risks.
Exactly. But taking that a step further, they can't just document it and walk away. The framework requires them to apply explainable AI or XAI techniques as a mitigation strategy.
And the source material lists a couple of really interesting examples of XAI. They mention using word clouds and counterfactual prompts as part of ongoing continuous improvement.
Counterfactual prompts are an incredibly powerful tool for understanding a black box.
Let's explore that for a second. Say an AI just denied someone's loan application, and the bank doesn't fully understand the math of why. A counterfactual prompt would be testing the AI by changing just one variable.
Right.
Asking the AI, if this applicant's income was $5,000 higher, would you have approved the loan? Or, if this applicant lived in a different zip code, would you have approved the loan? You poke and prod the black box to observe its boundaries.
And by altering the inputs and observing the changing outputs through those counterfactuals, you can infer the hidden rules the system has taught itself.
That is so smart.
If the AI suddenly approves the loan just because you changed the zip code, you've just uncovered a potential bias in the model, even without seeing the internal code.
Wow.
This has to be verified against the system's intended purpose to ensure it hasn't drifted into unintended behaviors.
But if that counterfactual reveals a massive error or a bias, how do you actually go back and fix it?
Wow.
Because that leads us directly into our final core concept from the document today, reproducibility and traceability. I like to think of this as the AI flight recorder.
The flight recorder? I like that.
Let's say the AI bakes a terrible cake. To figure out why it baked a terrible cake and to ensure it never does it again, you need to be able to reproduce the exact steps it took.
The framework states that reproducibility is a crucial requirement for achieving system resilience. In software systems, the ability to reproduce an outcome or an error is key to identifying and isolating the root cause.
And the list of what they have to record to make that possible is staggering. The framework demands incredibly strict version control.
Oh, yeah.
For every single version of a model, the company must track the code version, the dependencies, the parameters, the hyperparameters, and the exact source data used.
To clarify a couple of those terms for our listeners, because they are thrown around a lot in machine learning parameters, and hyperparameters are different things.
Right.
Think of hyperparameters as the overarching settings the developer controls before the training even begins. It's like the chef setting the oven temperature and the cooking time.
Okay, and the parameters.
The parameters are the internal variables that the AI learns and adjusts on its own during the training process. That's the AI figuring out exactly how much flour and sugar it needs to combine to get the right result.
Okay, got it.
The framework requires companies to log both the settings the human chose and the variables the machine learned.
They also have to log the exact source data, which includes both raw data and synthetic data used to train the model. And they have to track the journey of that data.
Yes.
The document outlines that companies must log the data used to produce inference results. And an inference result is just the AI's final answer or prediction, right?
Exactly.
And whether that inference happens through batch scoring or an API endpoint, it must be logged and linked directly back to the underlying model and source code.
To unpack those two methods, batch scoring is when a company runs a massive amount of data through the AI all at once, usually overnight, like a bank running fraud checks on millions of credit card transactions. An API endpoint is a real-time request, like a single user hitting submit on a website to get a translation. The framework requires an unbroken chain of evidence for both scenarios.
Wow.
From the moment data enters the system, through the specific version of the model that processed it, right down to the training data that taught the model how to respond.
Okay, I have to play devil's advocate here for a second.
Sure.
Logging every single input and output for a reasonable duration so they can be reviewed later. The server costs for a model processing millions of API calls a day must be astronomical. Does the framework address the sheer scale and cost of logging all of that data?
It's a valid concern, and it's a significant point of friction for companies adopting this framework. The scale of data retention required is immense.
It has to be.
However, the framework positions this as a non-negotiable cost of doing business responsibly.
The price of admission.
Exactly. The trade-off for deploying high-impact AI is that you must maintain the infrastructure to audit it. This is especially critical when we look at Process 3.4.1, which focuses on human-in-the-loop logging.
That was one of the most fascinating parts of the document for me.
If a system requires a human to sign off on an AI's decision, say, a radiologist reviewing an AI's medical span analysis, the system must log what the human did. The critical evidence is recording whether the human accepted or rejected the AI's recommendation.
Think about the accountability that creates. If an error occurs and a patient is misdiagnosed, this log prevents the human doctor from just throwing up their hands and blaming the machine.
Right.
And it also prevents the tech company from simply blaming the human operator for not paying attention. It captures the exact intersection between human judgment and artificial intelligence.
It creates a totally verifiable audit trail. And finally, the framework mandates continuous evaluation. Companies must define the process for developing models and evaluate that process continuously.
So they can't just build it and forget it.
Never. This involves calculating multiple inferences to check if the output falls within the accepted limits set by the system owner.
They have to identify a combination of both technical metrics and business metrics to assess the models against. It's not enough for the AI to just run efficiently with low latency. It has to actually achieve the business goal responsibly and fairly.
Exactly.
So what does this all mean for you, the listener?
I think the massive value of unpacking this source material today is realizing that AI governance isn't just some abstract philosophical debate happening in academic halls or think tanks.
No, it's very real.
It is a highly documented, evidence-based checklist. When companies say they are deploying responsible AI, frameworks like AI Verify mean they actually have to show their source code version, trace their data lineage, run mental model interviews with users, and document their exact mathematical rationale for choosing a black box model.
It moves the conversation from vague corporate promises to quantifiable audits.
Yeah.
However, as we synthesize all of these requirements, it does leave us with a fascinating paradox to consider.
The framework acknowledges that some state-of-the-art models are inherently unexplainable, requiring trade-offs between accuracy and transparency.
It's the ultimate tightrope walk.
It is. So here's a thought for you to ponder long after this deep dive ends today.
Yep.
If an AI system becomes so incredibly advanced that its internal logic genuinely surpasses human comprehension, making perfect explainability mathematically impossible, at what point do we decide that the life-saving accuracy of the AI is worth the sacrifice of not fully understanding how it reached its conclusion?
Accuracy versus comprehension. That is the exact tension driving the future of this technology. Thank you so much for joining us on this deep dive today. Keep questioning the technology around you. Demand those metaphorical nutritional labels, and we will catch you next time.